I'm Anil Kumar, and in this video, we'll review the concepts and solve a question based on new SAT format. The topic is line of best fit. I hope you remember what is linear correlation and correlation factor are. Here are the definitions. Linear correlation is a relation in which a change in independent variable tends to correspond to a proportional change in dependent variable. And a correlation coefficient R is a measure of how well a linear model y equals to mx plus b fits the data. So that's kind of the basics. Now we'll take few examples and understand these terms. So let me sketch few graphs here to share with you different types of linear correlations, and then we'll move from there. Okay, let me make a big one here which will be part of our question. Okay, so let's plot some data values. Let's say these are some points here, and we have some points moving downwards, kind of like this. Okay, we could have jumbled up points, kind of like this. So these are three different types of examples. What we see that in the very first one, the linear correlation is they are all in a straight line, correct? So when they are in a straight line, you can actually write an equation in the form of y equals to mx plus b, which could represent all the data, right? So this kind of a correlation will have R, the correlation coefficient, as positive 1. So I'm writing R equals to 1. It is positive since it is increasing order, right? So positive 1. All the points will fall on a straight line. So kind of, let's say like this. So that is the value of R. So we will call this as positive perfect correlation. So let me write on the term. It will be called as positive perfect correlation. Now if you have data points like this, where the independent variables which are along the x-axis and the dependent variables which are along the y-axis are kind of jumbled up, but you could have a straight line where the mean distance is almost same from the line. So this is the line of best fit. Now in this case, if you find the correlation coefficient, you may find that its value will be negative for sure. Let me just give one value here. Let's say it is 0.9, right? So it is very, very close to a situation which we just saw. It is, we'll say, a strong, but it's negative coming downwards, right? Correlation. So we could write this as negative strong correlation. If the data points are kind of jumbled up as shown here, you don't really see any trend between the independent and the dependent variable, right? For example, you could have height on this side in meters of the students and let's say marks on the other side. Now you'll find there is no correlation between height and marks. Now in such case, if you find or calculate using calculator correlation coefficient R, you will get some value which will be like 0. We'll just write a value at random, 0.05, right? So this is as good as no correlation at all, or a very, very weak correlation, right? So this will be treated as preferably no correlation, because you cannot have a linear model to show this representation. And in this case, you can say that there is very little linear pattern which you could say about it, right? So we'll say a very weak correlation. So that's better to say. So we'll say weak correlation. Or at times you may say there is no correlation, right? So is almost equal to 0, right? So the scatter plot does not appear to show any type of relation, right? So we could infer that there is no relation between these two, you could say. So we can say no correlation. That's another way of saying it. Okay. Now basically what you see here is that the correlation coefficient could be written in the form of whether it's positive or negative, and the other terms which you use are kind of like this. So let's say we have 0 here. Then on the right side, if R value is 1, let's say it is 1, then it is called as perfect correlation. This is perfect. But if it is kind of 0.6, let us say, so we can divide into 3 equal parts, right? So it is like 1/3 or 0.33, and this could be written as 0.67. So if you divide it into 3 equal parts, you can say this region is at 1, it is perfect. And the interval here between 0.67 to 1 will be treated as strong. And between 1/3 and 2/3, it will be treated as moderate. And this portion will be treated as weak correlation. Okay, so that is how you have to write them. So it is weak and this is positive. So on this side, let me write down the term positive. But if these values for R is negative, then we say it is negative correlation. That is, when X increases, Y decreases. That's the idea. As X increases, Y decreases. So that is the negative correlation. So if it is -1, it could be, you could write this in fractions or decimals. So it could be -1 minus 0.67 and minus 0.33, right? So the terms are same, right? So if it is between 0 to 33, this interval will be treated as weak. And here we'll call it moderate, but negative. This one is strong. And that is perfect. So that is how you describe the correlation. Okay. So I hope you've learned the first part. That is, if you have a linear correlation, it could be represented with a model y equals to mx plus b. And correlation coefficient actually tells you how strongly the equation represents the data, right? So I hope that part is clear to you. Now what I will do here is we'll just plot some points here. Okay, this is just random points. The idea is to approximately write down the equation and describe this kind of a correlation, right? So let's say this is 11 for us, this is 12, this is 13 on the x-axis, okay, 14. And along the y, let's have the points as, let's say, let me take this somewhere here as 50, okay, and let's somewhere here 50, and then this will be 100, and let's say this is 150. So I've just taken few points and made a scale here for x and y. Now in a multiple choice question, you may have few choices. Let me say A, B, C, and D are my choices. And let us say that we are able to write down that we say is kind of our line of best fit. And let the equation of this line be y equals to mx plus b. Now I'm not going to find the equation of this line. You can take 2 points and definitely find the equation. But the idea here is to practice solving a multiple choice question based on this topic. So So the idea here is you have to say the choices could be that m is greater than 0, b is greater than 0, m is less than 0, b is greater than 0, m is greater than 0, and b is, b is less than 0. Okay, so we just take all the combinations, and we could have m is less than 0 and b is greater than. Okay, so what we have taken is we have taken m greater than with b greater than and less than, and this is, let me write like this. So we have 4 different options. Okay, so these are all the possible options, correct? I hope you agree with me, right? Now tell me, what is the correct option? What is the correct option on this? That is the question for you for the SAT, for example. So you are given set of data points, scale, right? So that's 0 for you. I should not write here. Okay. You need to tell me which one is right. Now when you observe, you see that the line is positive slope, correct? So it is m is greater than 0 is kind of obvious. And what is the value of y-intercept? You can pause the video, answer the question, and then look into my suggestions. Okay. Now the important thing here is that making a choice for a slope is kind of simple in this case because line is showing you a positive trend. As x increases, y increases. So m is positive. So we know the option could be m positive, this one, or that one. So these two. Out of these two, we have to select the right answer. Now what is the value of b? B is the y-intercept. Is it okay? Y-intercept. Now the trick part here is, if you see the line as such, it may seem as if the line intersects at 50, which is more than 0, right? Higher than the x-axis, positive y-interface. So you may be tempted to provide A as the correct answer. However, if you observe along the x-axis, then the scale is kind of with a break here. We have 11, 12, 13, 14. This is not indeed 0, right? This could be 10. Now if I really find the y-intercept, that is for x equals to 0, what is the value of y? Will it be positive or negative? That's a good thing to think about. So if you see the y scale, it will be kind of 0 here, right? Where the x value is going to be 10, not 0. So for x equals to 0, y value should be negative. You understand? So the answer is C. Now this is a very important question, and that's why I'm sharing with you. There are times when you are doing multiple choice question, you could be tricked as it is here. The alternate way was to spend some more time and find the equation. For example, you could have taken one point, let us say at some value, let's say we could take this point, let's say approximate it to let's say 112, and similarly you could take a point, this seems to be at 10. Do you see that? So from these 2 points you can find the equation also. So at times you could select few points. Let me just take few points here. So approximate 2 points. Is it okay? So, and since we are interested in just finding the intercept, whether it's positive or negative, approximation can help. So you can see from here that the equation will reveal that the y-intercept is indeed negative and not positive. Is it okay? So if I take a point which is x as 10, then I'm expecting a value of 50, right? At x equals to 10, I'm expecting a value of 50 with m as positive. If x is equals to 0, I should be expecting a negative value of y, right? So this will be kind of a tricky situation, right? So I hope that part is clear to you. So don't get caught up with the values and the deceptive thing of this line intersecting y-axis at 50, right? look at both x and y axis to get to the answer. That's the whole idea. I hope you understand and appreciate it. Now, as an exercise, what you can do is you can actually find the line of best fit, equation for the line of best fit. But I'll leave that as a problem for you. So the question for you is to find the line equation for line of best fit. Right, so on a graph paper you can plot some points, take a scale like I have taken, and then you'll realize that the y-intercept is indeed less than 0, not greater than 0, right? So that's good to know. I'm Anil Kumar, and I hope that helps. Thank you, and all the best.